Yes.
Yes. Hello, everyone. Good morning. I'm Dr. Suguna Nanthini from India. I would like to share some concepts for automated epileptic seizure detection and prediction. We know that technology has changed our lives, and artificial intelligence makes people's life more efficient because it is a simulation of human intelligence processes by machines. From this, it is clear that machine can learn from data just like humans. So in artificial intelligence, an automated expert system is a computer system imitating the decision-making ability of human experts. We know that automatic epileptic seizure prediction device is important and useful for people with epilepsy. There are few devices are available which can detect the repeated shaking movements during the seizure. These devices may work with tonic-clonic seizures. It means partial seizures, right? The drawback is no alert device has been designed to prevent seizures, and seizure without big movements such as absent seizures and many types of focal or partial seizures, and not detected by this device. There are numerous self-learning algorithms. So approximation calculations, I mean self-learning algorithms that are used in soft computing techniques in order to provide solutions for complex computational problems. These self-learning algorithms are programmed algorithms that receive and analyze the input data to predict the output values. Some of the components of soft computing are machine learning. Some of the components of soft computing are machine learning, fuzzy logic, evolutionary computation, probabilistic theory, and deep learning. Deep learning is an advanced technique of artificial intelligence. There are three main learning algorithms in supervised learning. In machine learning, there are supervised, unsupervised, and reinforcement learning. In these learning types, classification and regression come under supervised learning. Clustering and associations come under unsupervised learning, and there are so many hybrid methods in reinforcement learning. Here, let me explain some concepts for how EEG signal classification can be done. In this learning, let me explain some concepts how EEG signal classification works for seizure detection. The entire seizure detection procedure can be subdivided into number of processing modules. That is pre-processing the EEG signal, feature extraction, and selection of relevant features and classification. Pre-processing means the pre-processing the EEG signal from artifacts, feature extraction, and then relevant features are selected, and then classification can be made. So in unsupervised learning, the next one is unsupervised learning. In this model, this is also a machine learning approach. They do not have any supervisor to guide them, just like unlike supervised learning. They do not have any supervisors to guide them. Models themselves, they learn themselves to find the hidden patterns from the provided data. So machine can learn from data, right? The goal of unsupervised learning as the model is to model the unstructured structure, unstructured in order to structure, in order to learn more from the data, input data. Here in automated epileptic seizure reduction, we use EEG signals as inputs. Here, algorithms are to discover and to present the interesting structures in the data. Unsupervised learning can be classified into clustering and association. Clustering means grouping. We know that grouping, such as grouping the customers by just a behavior, just a purchasing behavior. We can group the data. Association means, for example, people buy X also tend to buy Y, just like that. Grouping the input. The next one is reinforcement learning. The reinforcement learning is a type of machine learning method where an intelligent agent interacts with the environment and learns to act within that. Here, agent is an entity. This agent is nothing but an algorithm. Agent is an entity that can perceive, explore from the environment and act upon it. Environment means a situation in which an agent is present or surrounded by. Actions are the moves taken by the agent within the environment. State is a situation returned by the environment after each action taken by the agent. Here, agent is nothing but an algorithm. It's a self-learning algorithm. It can learn efficiently from the data. It can learn by its own. For example, if I want to tell some example for reinforcement learning, let me explain with the example. Suppose there is an artificial intelligent agent present within the maze environment, and his target is to find the diamond. The agent interacts with the environment by performing some actions, and based on those actions, the state of agent gets changed by through learning, and it also receives an award or penalty as a feedback. Then the another component of soft computing is fuzzy logic. Fuzzy logic is it is a method of reasoning that resembles human reasoning. The approach of fuzzy logic imitates the way of decision making, just like humans. That involves all intermediate possibilities between yes and no. Here you can see this is a Boolean logic. This is a fuzzy logic. We can the fuzzy logic works on the levels of possibilities of input to achieve the definite output. So the advantage of fuzzy logic is it requires a lower hardware than classical Boolean examples, Boolean logic. Fuzzy logic can produce accurate results from input data. So the next very important component of soft computing is evolutionary computation. Evolutionary computation is a subfield of computational intelligence, branch of machine learning and artificial intelligence. And here the main technique is used is genetic algorithm. The genetic algorithm is a search-based algorithm used for solving optimization problems in machine learning. This algorithm is important. is very important because it can solve difficult problems that would take a long time to solve. Genetic algorithm is popular approach in evolutionary computations. Genetic algorithm mimic natural evolution to solve optimization and search problems. In all these computational, even in supervised learning, we can use genetic algorithm for feature selection. Feature selection, we can use genetic algorithm to select relevant features for the classification. And then as ion colony optimization, this is also a computational intelligence technique inspired by the ant behavior. Now, it is a novel computational technique inspired by behavior of ants, applied for solving real-time optimization problems. This behavior pattern inspires artificial ants for the search of solution to the various types of optimization problems. And then now the advanced technology is deep learning. The deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. Evolution of machine learning, or even deeper machine learning, is deep learning, analyzing data with a similar logic structure to how human makes decisions and draw conclusions is deep learning. The role model of these learning types is human brain. Just like human brain, they enable data to pass between the nodes. All those nodes mimic just like neurons. The layers in artificial neural network that can learn and make decisions on its own. This design makes deep learning models more capable than standard machine learning algorithms. Typically, deep learning systems require large data sets to be successful. But once they have made, they can produce immediate results. In this deep learning, the need for human intervention is very low. An important advancement in the field of deep learning is called transfer learning, which involves the use of pre-trained models. It means that focuses on stored knowledge gained while solving one problem and applying those knowledge to the different but the related problem. So seizure reduction device. There are some devices are available. Seizure alert device may help notifying others if a seizure happens. If a seizure happens, the device can help by giving alarm like that. It can detect repeated shaking movements during the seizure. Many work with it may work with tonic-clonic seizures or focal motor seizures with enough movements to trigger the device. So the main drawback is it cannot prevent the seizure. It can just give an alarm for the caretaker. So thus, soft computing is based on natural as well as artificial ideas. It refers as a computational intelligence. The machine learns through algorithms. Each algorithm is based on some learning methods, just like memory-based learning, Herbian learning, competitive learning, and so on. It differs from conventional computing, that is hard computing. It has tolerance of imprecision, uncertainty, approximation, robustness, low solution cost, and better rapport with reality. The role model for the soft computing is human brain. Now, numerous algorithms are available. To train the epileptic seizure detection system, we need perfect input data, appropriate features of input should be extracted. Suitable algorithms for various types of seizures uh, should be deducted. Perfect to give a perfect warning